Welcome back. We're wrapping up the manual calculation of analysis of variance. We're going to show you how to construct an Anova table. Sometimes you'll be expected to do this by hand. Mostly I'm teaching you this because when you use Excel, they're going to organize everything into a table formatted similar to this. So I want to show you ahead of time what to expect. But there is a chance on a test or an exam that you'll actually have to write one of these things by hand. Let me just kind of first start out by writing down the general headings. You have a heading called treatments. Right? Then under that you have a heading called error, and then under that you have total. All right, those go off to the left, and then up here you have SS, and I'll explain all this in a second. You have DF, you have MS, and then you have F. I know it looks crazy, but let's go ahead and show you how it works. So these guys, let me make sure I don't screw this up. This goes down like this. This goes down like this. This goes all the way across. And let me go and draw it here too. This goes all the way across. And then the error goes almost all the way across. And then this guy comes all the way down. And then this guy comes down to there. I think that's about right. And you can close that one off if you want. But basically that's what you'll probably see in your books a lot of time when they write all this stuff. The way that you read this table, the headings across the top, you read the intersection. SST is the sum of squares among treatments, right? Sum of squares among treatments. All right, so let me write that down. In here is SST, right? Now remember, SSE was the sum of squares of errors. So that's SSE. So you just read it there. And then SS total, you don't really write SS total, you write that as the total variation I taught you about. Total variation. And notice that the total variation that we talked about was the sum of SST plus SSE. So the way you read this is you add things up in this column to get the totals at the bottom. So SST is here, SSE is here, you add them up, you get the total variation. That's why it's kind of nice to organize everything in a table instead of writing numbers down all over your paper. Now here you have DF, that means degree of freedom. Degree of freedom of the treatments, remember your test statistic was SST over SSE. So the degree of freedom here is the degree of freedom of the numerator, which is DOF of the numerator, which was K minus 1. Right? We used that when we had to find F alpha. And then you have the degree of freedom of the error, which is the denominator in that test statistic. So this is the degree of freedom of the denominator, which was N minus K, like this. And then you can have DF total if you want to write that down. The total degree of freedom of the problem. You could say that the sum of these two is the degree of freedom of the total. You don't really need that, but sometimes you just fill the table out like that. All right, then you go over here, MS, that's the mean square, right? So MST is what you would write down here, the mean square among treatments, MST. And then MSE is the mean square among errors, or of errors, MSE. Typically, you don't really add these numbers together because total variation is actually defined to be the sum of these, so we write it down there. That's why I don't really have this bar connect, because you really don't usually add them together. You could add them if you want, but it won't really mean anything. And then F over here, it doesn't necessarily mean F treatments necessarily, but it's basically the test statistic. It's the test statistic F. That's the big test statistic. So this is how you construct a analysis of variance table. So what I'm going to do is write everything down again, and we're going to put the numbers in from this exact problem. So we have treatments, we have error, and we have total. And then up here we have SS, we have DF, we have MS, and we have F. So we're going to extend this one all the way across. We're going to extend this one all the way across. The error is going to go almost all the way across. This guy's going to come down. This guy's going to come down. This guy's going to come down. This guy's going to come almost down. And I went a little bit too far here, but who cares? So SST for our problem. SST